Welcome to lecture number 10. 10th lecture on coordination chemistry. Today, we shall be completing the CFT and maybe calculation of crystal field stabilization energy. Am I audible, guys?
Yes, sir.
Yes,
Yes,
sir.
Yes, sir.
And I could not get time to see a few questions which you have raised. I'll check soon. Today, we shall talk about coordination chemistry. We have seen in any octahedral field we have started, we can find the del O value from the absorption peak from the lambda max. And lambda max depends on three factors, which the nature of the ligand and we have a spectrochemical series for ligands, effect of metal ion, more is the oxidation state. Now, keeping the oxidation state fixed, if the metal ion goes from 3D to 4D to 5D, then there is an increase in del O and effect of oxidation number. More is the oxidation state, more is the del O. But Udit has a question. He wrote to me that if he says if oxidation state remains the same and the ligands remain the same, then how can you know is the del O same or del O different? There lies the spectrochemical series of the metal ions. We had seen here manganese 2 plus is here, cobalt 2 plus is slightly ahead of it. So even if the ligands are same, oxidation states are same, then despite that, each metal ion has its own capacity of splitting the d orbital, depending on the energy levels, their polarizing power and all that, size and different aspects. You got it?
Yes, sir.
So even if the oxidation state is same, ligands are same, metals have different del O value. Could be different, could not be different, maybe same. By coincidence, they might two metals might be same. So when del
Sir,
O,
ଯଦି metal ion same ରହିଲା ଆଉ ligand change ହେଇଗଲା but oxidation state same ଅଛି then
hmm,
metal
oxidation
ion
state
same
same,
ଅଛି oxidation state same ଅଛି but ligand change ହେଇଗଲା
then ligand spectrochemical series, ସେଟା କ'ଣ ପାଇଁ ପ୍ରଥମେ ପଢିଲେ? The series, the long
okay
series
sir
of ligand spectrochemical series, ligand has a role to play. We still do not know why these guys, these cyanide ion, carbon monoxide, triphenyl phosphine, nitrite ion, they are very strong field ligands with the cause will be known. We know these are sigma donor and pi acceptor ligands, but we do not know the cause, how it is able to influence or have a greater repulsion to split to a greater extent. That will be known in MOT. But we have already ordered them relatively with their values found out for fixed, two things keeping fixed, varying the third thing. We have found out their Delo values, but we do not know why chloride, bromide, iodide, they are weak field ligands, very weak field ligands, while these guys are very strong field ligands, while this water amines, these are all intermediate field ligands, right? Any question?
No, sir.
We are joined by guys like Iji, Prabhat, Giji, RS, Sai, Amlan, Krishna. So today, yeah, let me remind you that if del O, octahedral splitting O, is greater than P, then T2G set is filled up first. Hunt, poly, as much as possible. After completing 6, then it will go to easy. If del O is small, pairing energy is more, then the climbing is just after 1, then 1, then poly. You know, the weak field ligands like fluorido, iodido, which are in the beginning of the uh, ligand spectrochemical series, they form high spin complex. They form high spin complex. Del O is less than their pairing energy. And for high field ligands like carbon monoxide, nitrito, and all, they form low spin complex. T2G first field, then EG. But the intermediate field ligands, they're tricky. For good, strong metal ions, they form low spin, but very weak metal ions in plus two state, very weak metal ions like cobalt 2, sorry, at least cobalt 2 plus stuck. But cobalt 2 plus with ammonia will not act as a high spin complex. It will act as a low spin. But cobalt 2 plus with aqua, that will act as a high spin complex. So the data will be given to you. Some tricks I have already told you. Let us now apply how we can judge the tetrahedral complexes. CFT. Now, if we draw the outline of a square, the three coordinate axes are lying at the center. I mean, this is at the center. Say, for example, this is the y-axis, for example, and this is the x-axis, sorry, z-axis. In case of octahedral field, the ligands were approaching along the direction of the axis. But here in tetrahedral field, metal ion is sitting here. And the ligands are approaching in alternating corners. Then only it will be forming, you just If you just, there is no theory of covalency here, but I am showing you how you can visualize the tetrahedral geometry by putting an arrow mark, which is VBT, and also MOT, LFT. So in crystal field, we don't bother about the bonds. We only take the the repulsion between the approaching ligands and the field inner d orbitals. Now, since they're approaching, I'm showing a short sign, not along the axis, away from the axis. The repulsion factor is less. Therefore, keeping the metal ion oxidation state fixed and ligands fixed, del T is nearly half of del O. Same metal ion, same oxidation state, but 6 ligands, same ligands. Del O will be 2 times greater. This will be almost half. This is tetrahedral splitting. Splitting occurs, but very small, half of it. And so much so that invariably it is less than the pairing energy. Pairing energy is always constant for every metal ion. It varies between 17,000 to 2100, 21,000. So it's centimeter inverse. So what happens here, the 4 ligands approach from the 4 alternate corners of the hypothetical cube, inside which the metal ion and the coordinate axis exist. Metal ion is at the center and the coordinate axis exist. So what happens, since the orbitals having d orbitals having z component, uh, no, uh, no, I'm so sorry. The orbitals which lie along the axial planes and in between the axis. Which ones? Which lie in between the axis, not along the axis?
dxy, dyz, dz.
dxy, dyz, dzx.
Yes. That was called T2G set. Here it will be called T2 set. G is absent because the tetrahedral field does not have a Z-red symmetry. It doesn't have a center of inversion. So, but in many books you will find T2G. G is missing to T2 set. Will be relatively repelled more than the d orbitals which lie along the axis. Which lie along the axis?
dz square and dx square minus z square.
Hello and welcome to those who are watching directly from the YouTube. Please say hi to me, those who are watching, which lie along the axis, that is dz square and dx square minus y square. Here it is called E set, not EG. E2, EZ. Just it will be opposite of the splitting that we found in case of octahedral field. T2G will go above because their lobes are lying in between the axes which are relatively closer. Of course, the ligands are not even approaching along the direction of the T2 set. They are closer, relatively closer. They are approaching here. The planes are at the middle. The axial planes are at the middle, but relatively they are closer to the approaching ligands than the than the E set in which the orbitals are lying along the axis. That is why, and moreover, the delta T, the tetrahedral splitting, is nearly half of del O because A, the approaching ligands are even not exactly in the direction of T2 set. What to speak of E set? T2 set, which is relatively repelled more, they are also not in the exact direction of approaching ligands. But the orbital lobes are lying at the middle in the axial planes in between the axes. And moreover, here there are 4 ligands instead of 6. These are the two reasons. In octahedral, there were 6 ligands which are attacking. Here 4. And moreover, there in octahedral field, the ligands are approaching directly along the direction of the axis, which affect the EG set to a great extent compared to those which are lying in between the axis. So splitting is more. But here, in both the cases, it will be weaker. As a result, it is half. Let us do the splitting for the first time and last time. We shall be showing the uncomplexed ion, then which will be raised to the barycenter. This is hypothetical. This is called free metal ion or uncomplexed metal ion. Then, because of the approaching ligands, the repulsion between the approaching ligands, electrostatic field and the existing d electrons in the n-1 d electrons orbitals, that raises the level, but there is a differential repulsion for which they split with respect to the barycenter. Here, opposite thing will happen. Here it will be EG, here it will be T2G. Sorry, I am doing the same mistake. It will be E and this will be T2. This will carry dxy, dyz, dzx. This will carry dx square minus y square and dz square. And this gap will be called del T, which is very small. Usually, and almost universally, del T is less than pairing energy. Hence, TD complexes are high spin complexes under coordination number 4. And most importantly, when we find the barycenter, there are two here. So this will be plus 2 by 5 del T above the barycenter, and this will be minus 3 by 5 del T below the barycenter. Because in the upper part there are 3, the lower part 2. So as much energy the 3 T2 orbitals will gain, the same will be lost by 2 E orbitals. So that there will be no net increase or decrease of energy, conservation of energy. So that's it. And we can write, already we know, the trick we already know, that who 3D metal ions with weak field ligands form 3D, sorry, 3D complexes. The glaring exception is cupric tetrachloride or cuprate, which has got a distorted tetrahedral, or it is better to call square planar. That is something different as we study the Jahn-Taylor effect, the distortion, how D9 configuration is behaves. That is a separate story. Otherwise, supposing I say it is cobalt hexafluorido, cobaltate. Cobalt is in the +2 state. Fluorido is a weak field ligand. So undoubtedly, it is once you know it is a TD, del T is less than pairing energy, then splitting diagram start from the barycenter. Don't bother about the free ion. Start from the barycenter and then split in opposite manner. Here it will be T2, here it will be E, and cobalt 2 plus is in the 3D7 configuration. And however you are doing, same thing you will be doing here. Poly. Same thing, but in a different style. Hand, poly, poly. There is a delta, no doubt, which will explain many things. The stability of the complex and their stability constants and color properties, all things. But the number of unpaired electrons will remain the same. These are called high spin complexes. I have told you the trick. But same cobalt ion with cyanide strong field ligand 3D, that will form a square planar complex. Then we will study crystal field theory, CFT, for square planar complex. I think this is time has come to study CFT for SP complexes. What is SP?
Square planar
Guys,
complex.
do you have any question to ask at this point of time? You can ask me in Odia. I understand Odia, but I can talk in Hindi. Any question? Say yes or no.
No, sir.
No, sir.
Once you diagnose the disease that this coordination number 4 will form a TD or SP, then apply the splitting that is applicable for that particular geometry. If it is TD, means it is a low field ligand and the metal ion is 3D. If the metal ion is 4D, 5D, even if it is a low field ligand, then it will form square planar because the teacher is strong. That will split to a large extent, despite chloride, bromide, iodide being a very poor student. Now let's see how the distortion will come. Now, see, SP geometry is a result of said out distortion in the octahedral field. देखो डिस्टोर्शन टा कौन मु कहूची डिस्टोर्शन टा काहे की हुए इवन ऑक्टाहेड्रल फील्ड रे 6टा कोऑर्डिनेशन नंबर अछि को केस रे D4 D7 D9 ए जोड़ा का अछि कहार हाई स्पिन कार लो स्पिन D9 रो तो किसी तार कोनोसी नेम नाही D8 D9 D10 एमानकर किसी हाई स्पिन लो स्पिन सेम D1 D2 D3 दे हैव यूनिक configurations तांकर number of unpaired electrons change होबनी but D4 to D7 there will be a change depending on the oxidation state of the metal ion ligands and the metal ion itself, so things will change whether it is high spin or low spin. Under coordination 6 there is high spin low spin. Under coordination number 4 the low spin is square planar that we are going to study because it is the mother is octahedral. Octahedral has a higher splitting, and if it is high spin then it is tetrahedral. A del T is nearly half. से जितने ये हेले भी यू नो डेल ओटा 30,000 हेले भी तार अधाटा 15,000 30,000 हेले भी तार अधाटा 15,000 तेणु ये 17,000 रु 21,000 तार पेयरिंग एनर्जी सो डेलो इज लेस देन पेयरिंग एनर्जी हेले हुंडू हुंडू पली 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 सॉरी हुंडू 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 पली 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 एठी जा होतला सेठी सेया खाली गोटे जंप करबा हमने ओडिया इसी से सीखा ये कृष्णा से सीखा कृष्णा मेरा ओडिया मास्टर है हेलो एंड वेलकम नाउ सी so let us start with a metal line is sitting here and these are the three coordinate axes. This is plus z, supposing this is minus z. This is plus x, this is minus x, this is plus y. Supposing this is plus y, this is minus y. And the ligands are, supposing we are considering the octahedral field. Supposing you try to stretch out, you will ask me why to stretch out. Just consider if you are stretching out outside, I mean away from the center, then that is called Z out distortion. Z axis re teme karucho because the ligands from the Z axis. Now this is our prerogative. Z axis is अगर X axis भी नहीं परिवा. Usually Z axis तक धरा जाए. We consider that as Z axis. So we stretch the two ligands up and down, supposing holding in our hand, one hand, the other hand, or slowly stretching out. Slowly stretching out, stretching out, stretching out, stretching out. And finally, we stretch, completely remove it and pocket it. We put it in our pockets. So we will see what changes will happen in phase-wise manner as we carry out Z-out distortions progressively, how the further splitting will occur, and when you put it in your pocket and get a square planet geometry, and what will be the final splitting diagram that we want to find out. Hello and welcome. Please chat me. Hello. Those watching from the YouTube, please chat me. Say hi. Now see, I'm telling you before I write something, let me tell you that when you are bringing the ligands closer and closer to the metal ion, the repulsion is increasing. But if you do the opposite, when you take away the ligands away from the metal ion, the repulsion will be decreasing. So since the d orbitals having z component along the axis were being relatively more repelled than the d orbitals, T2g as we call, whose lobes are lying along the axis, away from the axis, in between the axis, they are relatively less repelled. We shall be applying the opposite theory. When you remove, then the repulsion will be decreased, so that relatively there will be a further splitting of those orbitals from each set, T2z and EG set, having a z component. For example, in ED set, which was above, forget about tetrahedral, इसको गोली मारो. Again EG ऊपर, T2G नीचे. EG में जो है दो ऑर्बिटल्स, इसमें जो dz² है, that will get the brunt of the relief of repulsion. The brunt of relief of repulsion will be experienced more by dz². So its energy level will go down relative to dx² minus y². Similarly, the lower T2G set, the D components are present in dyz and dzx. So when the two trans ligands, these are the two trans z-axis ligands are stressed out, then because they are relatively closer to the z-axis, those d orbitals, although lying in between the axis, but they have a z component, dyz, dzx. So they are relatively closer. They will get a brunt of relief more than the other one, dxy, which has no z component, which is lying in the xy plane. So there also a splitting will occur. dxy will be going up, dyz and dzx will going down. So there will be further splitting in EG and further splitting in T2G. Then let's see what happens. Let me write down. Are you following me, guys? RS,
Yes, sir.
आप समझ रही हो?
Yes,
Yes,
sir.
sir.
नहीं, मैं इंग्लिश समझता नहीं, आप हिंदी में बोलिए.
हाँ सर.
सार क्या है? सार का मतलब क्या है?
गुरुजी.
गुरुजी. Guruji is a great word. If I am really your Guruji, then I am really excited about it. Guruji is not a small word. Z out distortion. When two trans ligands along Z axis, we presume Z axis, are gradually stretched out of, stretched away from the metal ion. It is called Z out distortion. I mean, when we study about Z in, there are some cases that we will study when we study in a separate extra class. You know, after the normal things are over, I'll be also making a public extra class in a different time for Jahn-Teller effect and octahedral distortions, which I will be inviting every one of you to attain. But after this, we will be closing some after three classes. One is the color, stability of complex, second, and the third one is metal complexes, metal carbonyl complexes. and mm, metal carbonyls and metallocene. MOT, we'll be doing extra classes on MOT, that is LFT, and Jahn-Taylor effect. When two trans ligands along Z-axis are gradually stressed away from the metal ion, it is called Z-out distortion. That means Z-in distortion bhi achi. Two trans ligands can, in some cases, become closer to the metal ion relative to other four sitting at the corners of a square. When this happens, further splitting in the OH field, let me write down in the OH field, octahedral field. When this happens, further splitting of each of the EG and T2G sets occur. The d orbital d components in each set gets a greater relief of decrease in repulsion force. And their energy level goes down. Down the other, having no Z component.
ସାର୍ ସେଟା EG ଆଉ T2G ଲେଖିଥିଲେ।
ହଁ କଣ ଅସୁବିଧା ହେଲା କି? କଣ ଲେଖିଥାନ୍ତି? ହଁ ଅକ୍ଟାହେଡ୍ରାଲ ସ୍ପିଡରେ EG ଉପରେ T2G ତଳେ ସେମାନଙ୍କର ମଧ୍ୟ ଫର୍ଦର ସ୍ପ୍ଲିଟିଂ ହବ। When this happens, comma, further splitting of each of the EG and T2G sets occur. Your hangover, ତମେ whiskey ପିଇଛ କି ରାତିରେ? ତମେ hangover ଯାଇନି T2 ଆଉ E ରେ ଅଛ, tetrahedral ଗଲାଣି। The tetrahedral is gone long since. ठीक है?
Yes, sir.
कृष्णा जी, tetrahedral में T2E, here we are talking about octahedral. EG T2G में further splitting आता है. A greater relief of the decrease in the repulsion of forces and their energy level goes down than relative to goes down relative to the other having no Z component. Now see, I'll be first showing from the barycenter and show the normal octahedral splitting. T2G coming here, EG coming here. This is octahedral. Then further splitting. Which will go up? Which will go down? Who can tell me? This is dx square minus y square and dz square. U1 having Z component will get a greater relief of repulsion forces. So its energy will be down. Conversely, the other's energy will be up with respect to this original level. Which one will go up?
dx square minus y square.
Yes. karan siye besi that one was experiencing repulsion to the maximum dz square karan tar z component ର ଅଛି x square minus y square ର lobes ଗୁଡାକ xy plane ଦୂରରେ ଅଛନ୍ତି ତେଣୁ ଯେତେବେଳେ z out dispersion କରୁଛେ तारी पाखरु एते जो रिपल्सन होतला तारी पाखरु रिपल्सन will be decreased to a greater extent. Repulsion will be decreased to a greater extent means it will be indirectly relatively attractive effect asibo, so its energy will go down. Actually attraction asiboni, decrease in repulsion relatively more is equivalent to attraction relatively attraction. ସମସ୍ତେ ଉପରେ ଅଛନ୍ତି ବାରି ସେଣ୍ଟରରୁ ସମସ୍ତେ ଉପରେ ଅଛନ୍ତି ତାଙ୍କ ଭିତରେ between them guys I'm sometimes I don't know I'm not sorry so similarly there will be further splitting among T2G dxy dyz dzx there will be further splitting. Tell me which one will come where?
dxy ଉପରକୁ ଯିବ dyz zx ତଳେ ରହିବ
ये ଯାହାର z component ଅଛି से in between axis थिले भी z yz plane xz plane से z axis पाखरे पाखापाखि अछंती किंतु xy plane टा तो पूरा z axis perpendicular अछि तेणु केवल तीनटा कोन कलिमो जोडाकर z component अछि जदि टाल मुंडरे पसुनी ताले मन रखता गले जो मानकर z component अछि dyz and dzx ए दीटा तळको आसीबो और dxy टा जार z component नाही तार the decrease in repulsion will not be as much profound as the decrease in repulsion for the orbitals having z component, so they will be relatively having less energy compared to the one which has no d, which has no orbital along the d direction or nearer to the d direction. Z components are 9, so there is a further gap asiwala. So this is called आमे जदि डिवाइड कर दबा एमती सेपरेट कर दबा एटा प्योर OH फील्ड ऑक्टाहेड्रल फील्ड एटा हला distorted octahedral field and many of the octahedral complexes are distorted. Z out distortion तारो दीटा ट्रांस कॉपर रो देखिबो Cu Cl6 plus Cu Cn4 H2O whole 2 whole 6 Cu Cn whole 4 H2O whole 2 2 minus देखिबो दीटा ट्रांसलिगेंड दूर रे अछंती तार डिस्टेंस एमाने जो साइनाइड जो अछि तांको डिस्टेंस थारु एमाने दूर रे अछंती सब D9 कॉपर 2 प्लस रो सब ऑक्टाहेड्रल कॉम्प्लेक्स रे तार ज्योमेट्री टा मन रखि थाओ इट इज नॉट ए रेगुलर ऑक्टाहेड्रल ज्योमेट्री देयर बी सिवियर डिस्टर्शन এবং অত্যধিক ডিস্টরশন হেলে সেদিটা পळेइबो पळेइकरी स्क्वायर प्लानर कॉम्प्लेक्स हे जिवो पळेइबो सेटा सो अल्टीमेटली जत्ते बेले स्ट्रेचिंग बॉडी बॉडी जीवो ए गैप टा बॉडी बॉडी जीवो वो लिखिबी सेटा ई जो गैप ए जो गैप एटा बॉडी बॉडी जीवो बॉडी बॉडी एभली स्टेज आसीबो जत्ते बेले पॉकेट रे पुरेइबो व्हेन यू पॉकेट द टू ट्रांस लिगेंड्स आउ नाही octahedral field is dead, square planar geometry has come. In that case you will find some peculiar thing. ये तो ऊपर उठी जाइथियो ये तो तळु पळि जाइथियो आ कोन हिथियो कहलो की कहि परबो कोन हिथियो अरे यार तळर गैप ऊपर गैप रो बढी बढी जो जीवो ताले कोन हिथियो मझिरे कोन हिथियो
सर xy टा z स्क्वायर ऊपर पळे आसो
yes दे z स्क्वायर टा तळु को पळि आसीबो एटा ता ऊपर को पळि जीवो हेले ultimately square planar मुटे लिखि दियो when z out distortion continues the gaps between the new sets increases, and while finally the two trans ligands are pocketed, are completely removed, dz square comes below dxy. This results SP complex. SP माने कौन? स्क्वायर प्लानर कॉम्प्लेक्स. तापर तार कहबी स्प्लिटिंग एनर्जी गुडा कहबी. एठी करबा ये आउरी ऊपर उठी जो बेसी ऊपर उठी पारने जगह नहीं आउ ये एमती तळु को खसी जीवो से ये एठी dz स्क्वायर ये एठी गोटी क्या dxy dxy तल डिपार्टमेंट रो लोक सी ऊपर डिपार्टमेंट रो लोक को क्रॉस कर गेलानी एंड ये आउरी तळु खसी जी दीटा एठी दीटा अछि बंधुगण सबुठो मैक्सिमम होची एई गैपटा एटा होची डेलो ए जो डेलोटा जो देखुछ ता संगरे पाखापाखि समान एटा एटा जोटा पेयरिंग एनर्जी टू अधिका सबु बळे और स्ट्रांग फील्ड लिगेंड्स आ वीक फील्ड लिगेंड्स तो कोऑर्डिनेशन नंबर 4 रे टेट्राहेड्रल करी किंतु एगुडा सब पाखापाखि सो जदि मु इन टर्म्स ऑफ डेलो करबी ए गैपटा is about 0.656 डेलो ए गैपटा एंड ए गैपटा आउरी कम एटा सिना हे पारलानी मो तो अधिका हे गला एटा आउरी कम 0.086 डेलो एटा आउटी तळु को आसीबार थिला तेणु जा हो या हे तो गलानी आ हां करिया कोन करिया छाड़ो सो dxy to dz square gap होची in terms of डेलो is 0.656 डेलो and with respect to dz square ଆଉ dxy dyz sorry dyz zx ए गैपटा होची 0.086 डेलो तो टोटल सबुतक मिसे तीनटा एठी गैप रहिला ऊपर गैपटा डेलो या संगे समान ता तळटा होची 0.656 डेलो बिटवीन जो रिवर्स हे जाईची बिटवीन द रिवर्स्ड ऑर्बिटल्स 0.656 डेलो एंड dyz dzx आउ d डे स्क्वायर ऊपर जो तळुक चली आसला ता भीतर गैप होची एथि सबुतक मिसई देले ताको कहंती डेल्टा sp स्क्वायर प्लानर स्प्लिटिंग इज इक्वल टू डेलो प्रथमटा देन 0.656 डेलो प्लस 0.086 डेलो सो सबुतक मिसई देले एटा पाखापाखि 1.742 डेलो तो टोटल स्क्वायर प्लानर स्प्लिटिंग टा इन टर्म्स ऑफ डेलो तार जो एक ऑक्टाहेड्रल फील्ड हे था डिस्टॉर्शन हे करी पॉकेट रे पसी न था से दीटा लिगांड था ऑक्टाहेड्रल फील्ड रे तो ताको पॉकेट रे पुरी न था पॉकेट रे पुरीले टोटल टा हबो एते की 1.742 डेलो and let me tell you that del O is greater than pairing energy but beauty लिख लेनी ची but 0.656 डेलो and 0.086 डेलो the two lower gaps are less than pairing energy. So এটি কেতেটা ইলেকট্রন ম্যাক্সিমাম রহিব এ 2 2 4 2 6 2 8 8 ରୁ ଉପରକୁ ଗଲେ ଯାଇକି ହବ 8 ପର୍ଯ୍ୟନ୍ତ ଆର ଭିତରେ ରହିବ. So these three lower 3 orbitals will be occupied 1 electron each before pairing occurs. So let me write down a delta very large. Eta sorry, eta. এইটা কোন দেখুଛି ମୋ distorted octahedral ରେ reversal ହେଇନି এইটা 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 very large this gap but ଏଗୁଡାକ ସବୁ small. So 2 2 4 2 6 8ଟା. So electrons are filled 1 electron each to dyz dzx ये गोटे सेट. देन तापर की अछि हेलो pairing occurs from below till dxy. Then 99th electron goes to the upper ରହିଲା ଯେ dx square minus y square ଯିବ. ବୁଝିହେଲା? ଏମାନେ ଛୋଟ ଛୋଟ ତେଣୁ ଆମକୁ ଯେତେ ଧର 5ଟା ଇଲେକ୍ଟ୍ରନ ଅଛି 6ଟା ଇଲେକ୍ଟ୍ରନ ଅଛି କିଏ ଦେଖି ଜାଣି ପାରିଲ ଏଟା ଗୋଟେ ସ୍କ୍ୱାର ପ୍ଲାନର କମ୍ପ୍ଲେକ୍ସ ଦଉଛି. ତେଣୁ ସେମାନେ ଦେବେନି. ୟୁଜୁଆଲି ଆମର D8 ଯଦି କନଫିଗୁରେସନ ଦବା ନିକେଲ 2 ପ୍ଲସ ର NiCN whole 6 କହିଛି. Two minus 4 whole 4. I'm so sorry. Whole 4. So nickel is in the plus 2 state. D8 configuration. आमे जानिछु एटा ଗୋଟେ स्क्वायर प्लानर कॉम्प्लेक्स. ताको आमे एतो केमति करिवा आमे स्क्वायर प्लानर रो स्प्लिटिंग डायग्राम करिवा. तळे दीटा करिवा dyz dzx. आमे जानिछु खसी आसलानी तळकु किए ना dz स्क्वायर. तार ऊपर अछि किए ना dxy आर आर लोक बहुत बहुत ऊपर अछि किए ना dx स्क्वायर माइनस y स्क्वायर. एटा होती स्प्लिटिंग डायग्राम ऑफ sp कॉम्प्लेक्स. तळे दीटा अछि dyz dzx तापरे खसी आसलानी eg सेट रु खसी आसलानी एठी तापरे dxy यार ऊपर को उठी गलानी. देन तापरे सबुठ ऊपर dx स्क्वायर. ए गैपटा होची डेलो. तेणु आम हाथ में 8 इलेक्ट्रॉन जो अच्छी हुंड 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 एमती गला 1 2 3 4 5 देन पॉली 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 6 7 1 1 2 3 4 5 6 7 8 और एथि डीटा परा. आई एम सो सॉरी डीटा कहली किंतु तीनटा मु ड्रा कली के किछि कहून. हुंड 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 पॉली 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 2 2 4 2 6 8 तापरे जाइकरी जीवो D9 रे एठी की जीवो. सो इट इज ए डायमैग्नेटिक कॉम्प्लेक्स. ने तबे कहि परिबोनी 1 2 3 4 5 एठी जाई परिबोनी कारण एठी गजबा डे लोटा बहुत अधिका पेयरिंग एनर्जी टा कम. କିନ୍ତୁ ଏମାନଙ୍କର ଗ୍ୟାପଟା which is 0.656 0 something something ଏଟାକ ବହୁତ କମ pairing energy ଅଧିକା ପୁଣି ଏମାନେ ଫଟାଫଟ ଯିବେ। ଫର ଏକ୍ସାମ୍ପଲ ମୁଁ କହିବି ଯେ ନାଇଁ ନିକେଲ 2+ କାହିଁକି ନବା, ସେଇଟା ଡାଇମ୍ୟାଗ୍ନେଟିକ ହେଇଗଲା, ମୁଁ କୋବାଲ୍ଟ 2+ ର କରିବି, ତାର 7ଟା ପେୟାରିଂ ହବ, ନମ୍ବର ଅଫ ଅନପେୟାର୍ଡ ଇଲେକ୍ଟ୍ରନ୍ସ କମିବ, କିନ୍ତୁ ଗୋଟେ ଅନପେୟାର୍ଡ ଇଲେକ୍ଟ୍ରନ ବଳିଯିବ, ତା ପାଇଁ ଆଉ ଥରେ କରିବା। ଦିସ୍ ଇଜ D7 କୋବାଲ୍ଟ 2+ ଟା 4 ପରା, ଆମେ 4, এটা ତ ସ୍କୋୟାର ପ୍ଲାନାର କମ୍ପ୍ଲେକ୍ସ ଷ୍ଟ୍ରଙ୍ଗ ଦେଖୁଛ ମାନେ 3D ବି ଦେଖୁଛ ମାନେ ସେଇଟା ହବ ଏଇଟା। ତେଣୁ ତମେ ସାଙ୍ଗେ ସାଙ୍ଗ SP କମ୍ପ୍ଲେକ୍ସ ର ଯୋଉ ଦିଟା DYZ DZX କରିଦେଲ, ତା ଉପରେ ଆସିଗଲା DZ², ତା ଉପରେ ଆସିଗଲା DXY, ତା ସଭା ଉପରେ ଆସିଗଲା DX² - Y²। ଏଟା ହଉଛି ତାର ସ୍ପ୍ଲିଟିଂ ଡାଇଗ୍ରାମ ଫର SP କମ୍ପ୍ଲେକ୍ସ। ଗଲା ପରେ ଆମର 7ଟା ଇଲେକ୍ଟ୍ରନ ଏଗୁଡାକ 1 1 1 1 ରହିବ, ତାପରେ ପେୟାରିଂ ଷ୍ଟାର୍ଟ ହେଲା 1 2 3 4, 4 ପରେ 5 6 7, ଗୋଟିଏ ରହିଲା। କିନ୍ତୁ ଯଦି ଫ୍ରି ମେଟାଲ ଆୟନରେ ଆମେ କଣ ଥିଲା ବାରି ସେଣ୍ଟରରେ ଯୋଉ ଆମେ କରିଥିଲେ, ଆମର ଯୋଉ ଫ୍ରି ମେଟାଲ ଆୟନରେ ଡୁଣ୍ଡ ପଲି 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 ସରି, ସୋ 2ଟା ଅନପେୟାର୍ଡ ଇଲେକ୍ଟ୍ରନ ରହୁଥିଲା, 3ଟା ଅନପେୟାର୍ଡ ଇଲେକ୍ଟ୍ରନ ରହୁଥିଲା ଅନକମ୍ପ୍ଲେକ୍ସଡ ଆୟନରେ। এইটা ଆମେ ମଧ୍ୟ ଏକ୍ସପ୍ଲେନ କରିଥିଲେ by dsp2 hybridization making a pair in the inner d orbital so that by the number of unpaired electrons was reduced by 2। 3ଟା ଥିଲା, ବର୍ତ୍ତମାନ ପ୍ରକୃତରେ ଗୋଟେ ଅଛି କମ୍ପ୍ଲେକ୍ସରେ। that also can be known by applying this theory because these gaps are small। ଏମାନଙ୍କ ଭିତରେ ହୁଣ୍ଡ 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 ଆସିବ, ତାପରେ ପଲି ପଲି, ଅଷ୍ଟମ ଇଲେକ୍ଟ୍ରନ ପରେ ଯାଇକିରି ନବମ ଇଲେକ୍ଟ୍ରନ ପଡିବ। ଫର ଏକ୍ସାମ୍ପଲ CuCN4 କପର 2+, 3D9, ସେଠି ଆଉ କିଛି ବାଟ ନାହିଁ। ତମେ କହୁଛ କାହିଁକି ସାର୍ ଆଉ ଗୁଡାକ କରୁଛନ୍ତି, ସେଟା ଆମେ ବୁଝିଗଲୁ, ବୁଝି ତ ଗଲୁ, ବଟ୍ वी विल फॉरगेट इट। ଆପଣ ଗୁଡାଏ ଆମକୁ କରାନ୍ତୁ ପ୍ରାକ୍ଟିସ। Okay, then you draw the splitting diagram of the SP field, which is the severe distortion of octahedral field where the two trans ligands have been completely removed. This is DYZ DZX, यार ना किसी short ना नहीं, DZ² and D यार जाइए सेठी, and then D X² - Y². Not a electron, 9 electrons will be filled like this in this order. Hund, 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 hund. Poly, 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 poly. Then it will have to go. Have to go. Then it has got one unpaired electron. It's paramagnetic and one unpaired electron. Zotaku. In the language of VBT, we are saying there was a much debate. Some people who took that d electron to 4p and carried out dsp2 hybridization for any other square planar complex, but many Huggins, he proposed and many accepted that if that unpaired electron is present in a higher energy 4p, then it would be easily lost and copper 2+ can easily form copper 3+, which is not happening. Therefore, let that remain in that D. We shall be taking the d orbital of 4d. So the sp2d bypassing the pz, and let it stand along, let it stand along z axis. We don't bother. Let px py and the dz² minus dx² minus y². So sp2d. So that is the VBT theory. But this is CFT is nothing to do with hybridization, nothing. Only splitting of d orbitals present where electron is present. They are the vacant orbitals were taking part. The lone pair orbitals of the ligands were approaching and overlapping. Here, they are static. They are producing static electricity, electric field, and which is causing a differential, splitting of different d orbitals. The degeneracy is removed once for OH and TD, but for a distorted octahedral twice, and finally the consequence of the extreme distortion of removing the two transligands is the square planar complex, where the reversal of the energy order comes between dz square and dxy. Got it? Yes or no? Any doubt?
Yes, sir.
Yes, sir.
Now I'm showing you, if I have left something in my handout, which I'll give you, I've already told you, I've shown the same example, but in here I have done cobalt 2 plus complex, copper 2 plus complex in addition to that. Here I have asked you a question, draw the splitting diagram of with electron filling in the appropriate d orbitals of the following complexes. Predict the number of unpaired electrons in each. It has been mentioned, octahedral. Octahedral LS means, del O is greater than pairing energy. T2s will be filled first. After that, all the 6 electrons gone, then 7th electron will go up. But if it is HS with a weak field ligand, then hund, D7 with a tetrahedral complex. We know that coordination number is 4 and is a weak field, 3D metal ion. I have also wanted to tell you that supposing this is platinum tetrachloride, as I have told you in BBT, platinum is in the +2 state, it is 5D8 configuration. Even if it is a weak field ligand, platinum 2 plus is a strong field metal ion, the splitting ability is quite high as a teacher metal ion. So this weak field ligand cannot prevent the formation of square planar complex, which is a result of octahedral distortion. So that also somebody asks you how to draw the square. This is square planar complex. এটা কোন? Same as you have done for nickel 2 plus, same thing will be applicable for palladium. But here, interestingly, we have not taken cyanide ion. Had we taken cyanide ion, also same. But even with chloride, bromide, iodide, all this, they will form sp complex, and their sp splitting diagram will be shown like tetracyanide nickelate. Clear hai? Guys? Guys?
Yes, sir.
Yes, sir.
Yes.
Those who are watching in the YouTube can give me a comment how it is going, how you are feeling. Are you liking it? If so, please give a comment. And you have to do this at home. D8 already you have done 100 times. Square planar complex. Splitting diagram means it is CFT. Hybridization means it is VBT. D9 octahedral, D9, D8, D9, D10 octahedral, there is no octahedral and in tetrahedral. They have unique things. But for square planar, something is different because the upper state will not be occupied at all. So therefore, I have asked D8 square planar complex. But in octahedral field, square high spin, low spin has no meaning. They have same, uh, electronic configuration. So also tetrahedral. Only T2G, T2 and E, they will be reversed. And octahedral with a tetragonal distortion. That means this you have to give. Middle one. There are how many? 9. Then since, 1, 2, 3, 4, these are all less. 1, 1, 2, 1, 1, 1, 1, 1. Then 2, 2, D8. Here, same. There will be 2 unpaired electrons. This is the diagram for the distorted octahedron, where there are 6 ligands, but there is a Z out distortion. Okay, I was really planning to talk about how to calculate crystal field stabilization energy in both octahedral and square planar and tetrahedral. So, but I don't think it is already 6:07. Can we do that, Krishna? It's very simple. Or tomorrow, Krishna, Amlan. No answer.
सर काट कर दो.
Oh. So we close today's program. Tomorrow we shall be doing crystal field stabilization for all the types, 3 main types, octahedral. And you try to revise this. I will ask questions. First, I will give you a lot of things. You have to draw some in some cases VBT diagram. Sometimes you have to predict whether it is a inner orbital complex or outer orbital complex or low spin or high spin. Giving intermediate field ligands with a weak field metal ions, you have to predict. These are some anomalous cases I have told you. And those cases which are known like fluoride, bromide, iodide, they are all proven weak field ligands. They will go for a high spin complex with even a manganese 2 plus, even with cobalt 3 plus, even with this thing. Only when it is second, platinum, palladium, they will form low spin complex. They are. And then tomorrow, we shall be also doing the collar. Collar properties, how you can predict from the CFT, from Delo value, lambda max, which is reciprocal of nu bar, how you will find out, predict if this absorption spectrum is this, then what color it would expected to exhibit. Do that. Bye-bye. Hello, and the guys who are watching from YouTube, if you are liking it, have you given a thumbs up? Have you subscribed to my channel? If not, then do so. Bye-bye. God bless you all. Hello.
Yes,
Hello.
sir.
Hello.